Welcome back, guys. Starting Unit 6 today with polygons. A polygon is a closed figure made up of 3 or more line segments, and those are the sides of the polygon. Okay, so different type of polygons. We'll start with a triangle. Triangle is made up of 3 sides. We're talking about a triangle. We have 1. And the sum of all the angles is 180 degrees. After that, we have a quadrilateral, any 4-sided figure. And you can see in the picture, you can break it up into 2 triangles. And 180 times 2 is 360. Next, we have a pentagon, which is a 5-sided figure. As you see in the picture, it can be broken up into 3 different triangles. And if it's 3 triangles, 180 times 3 is 540 degrees. We're just going to keep going down here and filling this out. Hexagon is a 6-sided figure. Again, in the picture, I see all these triangles within it, so I see 4. And 180 times 4 is 720. As you can see, after hexagon, starting at heptagon, they've stopped giving us a picture because they're hoping we will see the pattern that a heptagon is 7. And it has one more, since it's got one more side, it has one more triangle within it. And that means 900 degrees, 180 for each of those triangles. An octagon is an 8-sided figure with one more side. It has one more triangle within it, which means now we're at 1080 degrees. Let's see here. Next is a nonagon, 9-sided. Has one more side than an octagon, which means it has one more triangle. And we are now at 1260 degrees. Lastly, a decagon, 10 sides, which means 8 triangles. And it's going to be 1440 degrees if you added up all the inside angles. Okay, so based on this pattern, we can do any sided figure by knowing the formula. And the formula for inside or interior angles of a polygon is the number of sides minus 2 multiplied by 180. So for example, if we were doing a 15gon, we would take the formula from above and substitute out the n for the 15. So S equals 15 minus 2 times 180. If we just plug that into our calculator, it'd become 13 times 180. And that equals 2,340 degrees. Again, we'll do one more. I'll do number 3. I will take the formula. Instead of writing the letter N, I will give, in this case, I will put 48, since that's what they give me in the problem, minus 2 all times 180. So that means I have 46 times 180, which is a big number. It should be 8,280 degrees. 2 and 4, I'm going to leave for you guys to do so you can practice the formula a little bit. Again, you're just subtracting out that n, you're putting in the number they give you, and you're just doing your PEMDAS. I'm going to move on to what a regular polygon is. And when I say a regular polygon, I'm saying that all sides are congruent. And I'm going to use my symbol of congruent. And all angles are also congruent. Over here, in case we forget what this symbol means, I am going to put that it means the word congruent. And the word congruent means same measure. Okay, So with that being said, in number 5, they want us to find each interior angle of a regular pentagon. So remember, a pentagon is 5 sides. So first, I'm going to fill out the formula from the first page, right, to see how many all the angles together would be. So that'd be 5 minus 2 times 180. I would get 3 times 180. And that would give me 540. Then they want to know how many each individual angle would be. So if it's a pentagon, it would have 5 angles. So I would just divide my answer by 5, and I would get 108 degrees per angle. Okay, I'm going to leave number 6 for you guys to try using with the number 18 instead of 5 for a pentagon. But go ahead and just follow that steps. Follow the formula from the previous page, and then just divide it by the number of angles it would have. Okay, next we have the sum of the exterior measures. Exterior measures, no matter what the shape is, it is always 360. So if I have a triangle, if I have a quadrilateral, if I have a 1, 2, 3, 4, 5, I believe that's a pentagon, it is still 360. Doesn't matter the shape. If it's exterior, it's always 360. So we're going to practice finding these. In this case, the first one, the triangle, they gave us no outside angles, but we do have what we would consider linear pairs for each of them. So what I would do is I would take each angle and subtract it from 180. So 180 minus 79, 180 minus 61, and 180 minus 40. So 180 minus 79 is 101. 180 minus 61 is 119. Why am I writing a 7? And lastly, 180 minus 40 is 140. So I will fill those into the picture. And if I add all those up, I would get 360 degrees. On the next 3 shapes, you are going to do the same thing that we did with the triangle. You're going to take each inside angle, subtract it from 180, and the number you get would go to the next to the number you subtracted with. So when I subtracted 79, I got 101, and the 101 went right next to 79. So that's what you're going to be doing for the next 3. If you need help, call me over. I can check your answers, and you can move on. Pause where you need to pause, guys. They have a quick question, and it's saying, what can you conclude about the sum of the exterior measures of any polygon? Always add to 360 for exterior. Please do not forget that exterior is 360. Interior, we have that formula from the front page. So now we just have a few example problems we're going to go through. First one being, what is the measure of each exterior angle of a regular hexagon? So if you look at the first page, we know a hexagon. That means we have the number 6 to work with. So if it's talking about exterior, it is 360 divided by 6. Each angle on the outside would be 60 degrees. What is the measure of each exterior angle for a regular 24gon? Doesn't matter how many angles, all the exteriors will always add up to 360. So 360 divided by 24, each individual angle would be 15 degrees. Number 9 and 10 are a little different. Number 9 says, if the exterior angle of a regular polygon measures 12 degrees, how many sides does it have? So you're kind of working a little backwards. So we know exterior always makes 360. We're always dividing by something. And in this case, we're getting 12 after we divide. If I don't know something, I put a variable in its place. So in this case, I don't know what I'm dividing by, so I'm dividing by x. And I need to solve for x. So what I would do is get rid of this fraction, so multiply both sides by x. And I no longer have a fraction on this side, and I get 360 by itself is equal to 12x. To get x by itself, you would divide both sides by 12. My iPad won't let me do it, so I will divide both sides by 12. Divide both sides by 12. And x would be 30 in this case. Same thing for number 10. We don't know how many sides we have, but we know that each exterior is 40. So exterior always makes 360. We don't know how many sides yet, but we do know each angle is 40. Multiply both sides by x. And then in this case, divide by 40, divide by 40. X would be 9. We would have a nonagon in this case. Okay, at this point, these are our first set of notes. Please go ahead and rewatch anything that you need more time on. Call me over and I can explain anything further in case something did not make sense. And go ahead, and if you are ready, you can move on to the next page of practice problems.